Movement is an essential mechanic in almost every game genre and can make or break the feel of your game. In this video, you'll learn step by step how to create a top-down character controller which is capable of moving in 2, 4, or 8 directions. To start, we'll break down what we want the game to do into core steps so that we can plan out how we're going to implement those steps one at a time. First, we'll need to take input from the player to know what direction they want the character to move. Next, we'll need to adjust the character's velocity based on the input. In case you didn't already know, velocity is a vector that represents both the speed and direction that something is moving. I'll explain more on that later. Lastly, we'll need to tell the character to use the adjusted velocity value to move in our desired direction. These 3 steps are all you need for a simple but functional top-down character movement controller. Now, let's get into the details of each of these steps and how we can implement them. Just like we did for the overall process a moment ago, we're going to break down each core step into bite-sized pieces that we can implement. Let's start with step 1, getting player input. The first step to taking input from the player is to define what you count as input for a given action. While you probably have a good idea what kind of control setup you want to use, Godot needs to be explicitly told what kind of actions exist and what buttons correspond to those actions. Next, we'll need to write the code that listens for and interprets the actions. In the context of a movement script, this is the code that translates your inputs into the direction you want the character to move. Here you can see a visual representation of how different key combinations result in different movement directions. In our example, we have 8 directional movement. Now that we have our desired movement direction, we're ready to move on to the next step, adjusting the velocity based on our input direction. Let's begin breaking it into substeps. First, we need to make sure our direction vector is normalized. This one might not be intuitive to new developers, but essentially all it means is making sure that your direction vector will only specify the direction of movement and not influence your movement speed. If we skip this step, diagonal movement will end up being about 41% faster than orthogonal movement. Speaking of movement speed, you'll need to decide how fast you want the character to move and multiply it by the direction vector to get your adjusted velocity. Now we can move on to step 3, using our adjusted velocity value to move the character. First, we need to decide our collision type. You may have noticed that in some games, like the early Pokemon series entries, trying to run into a wall doesn't move you, while in other games, running straight at a wall will kind of cause you to slide along it. Godot offers different methods of applying motion that can be used for either, or for coding your own custom collision response. Next, we'll have to make a game design decision about when and how often to call our movement method. You can choose to constantly apply movement and changes in direction so that you have a lot more flexibility, or you could code it so that movement commands are only taken periodically and must be completed before you change direction, also like the early Pokemon games. For both of these sub-steps, we're going to take a simpler approach for the sake of this tutorial. Now that we have our plan of action, we can open our game and implement it. There is one final step though. If you're enjoying the video so far, please consider leaving a like, comment, or even subscribing to help this channel reach more indie developers like you. I really appreciate all your support. Also, as a small incentive, I'll be giving out some keys for free 8-directional game assets. If you're interested in that, let me know in the comments what topics you'd like me to talk about in future videos. If you haven't done so already, download and start Godot, then open your project or create a new one. Today I'll be starting from a fresh, empty project in Godot 4.4. Let's start by creating the character. Although you could tweak our process to work with other types of nodes, we'll be using a character body 2D node today. You might have noticed that there's an error warning on the character body 2D due to it not having a collision shape. Let's fix that by adding a collision shape 2D node as a child, then setting its shape as a circle. For our movement demo, this won't really matter, but in a real game you would need the collision shape to help the game engine determine when characters, objects, or areas are overlapping or colliding with one another. Let's also add a script to the character. We'll put our movement code in here later, but for now, I'm just going to delete the default methods and save. Now, let's begin following the step-by-step process we conceptualized earlier. Let's navigate to Project, Project Settings, Input Map, and add 4 actions: up, left, down, and right. We can click on the plus sign beside each action to associate a key with it. I'm going to use WASD. Note that you can bind multiple keys to a single action. For example, it's common for arcade-style games to allow movement to be controlled by WASD or the arrow keys. Now it's time to code the characters so that they listen for input. First, we'll define a method named takeMovementInput, which will do exactly that. We could break this process out into multiple if statements, one per direction like this. But instead, we're going to simplify it by using the built-in getVector method. This method lets us check all 4 of our inputs at once rather than spreading it across multiple lines. This will also save us the trouble of writing extra lines of code for each condition. Observant viewers may have noticed that up is in the negative Y field and down is in the positive. This is intentional. By convention, Godot considers down to be the positive Y direction. Now that step 1 is done, we can move on to step 2, adjusting the velocity. First, we'll need to normalize the direction variable we just stored. The getVector method we used earlier actually does do this for us, but I'm going to explicitly show it here for anyone who may have chosen to listen for the direction value in a different way. As is, it would work fine for up, down, left, and right, but if we tried to move diagonally, we'd end up moving about 41% faster than intended. This is because the game is trying to move at full speed in both the X and Y directions, making the combined diagonal speed greater. To fix this, we just have to normalize the vector. This means we'll be scaling it to be exactly 1 unit length. Next, we'll choose how fast we want the character to go. In 2D, this is defined in pixels per second, although what distance a pixel roughly equates to in-game is defined by your preference and the pixel size of the art. You can make your speed a constant or a variable, depending on whether you want to be able to change it later or not. I'm going to choose a variable. Now we'll multiply the speed by our direction vector and get our adjusted velocity variable. It's worth noting that, while velocity is a built-in property of the character body 2D node we're using, if your character is another node type, like an area 2D, you'll have to declare the velocity variable in your script. We can use the move and collide method or the move and slide method to move our character. Move and collide requires that you pass in an argument to tell it how far you want the player to move in a single frame. That is, 1/60th of your velocity if there's no lag. Move and slide, on the other hand, will automatically use the velocity property that's built into our character body 2D node, so you don't need to pass in any arguments. More importantly, move and collide will automatically stop the player if you're going to collide with something, while move and slide will try to slide you along the colliding object instead of just stopping. Under the hood, move and slide is actually made up of a lot of move and collide calls and other checks, and was built into the character body 2D class as a way to save developers like you time implementing the same thing. If you want to, you can use move and collide to build your own custom collision response too. Finally, we'll add the code that applies our motion. Earlier I mentioned there being some design choices involved. In our example, we're going to put our movement method in physics process, which typically updates 60 times per second, allowing the player to change direction whenever they want. This frame rate will adjust when there's lag and can be edited in the project settings if you choose to have a lower or higher frame rate. Now we can save our script and go back to the 2D view of our character scene. I'm going to go hold down Alt, which makes sure I'm grabbing the selected node and not one of its child nodes instead, then drag it to the center of our viewport for testing. I'll also go into Debug and turn on visible collision shapes so we can see the movement, since we don't have a sprite to show our character. Now let's start the project and test things out. As you can see, I'm able to move our character in 8 directions just like we intended. In a real project, your next steps would be to pair animations with their movement directions, and create a test map so that you can get a feel for how your movement speed feels relative to the size of the game world. I went ahead and prepared something like this using some assets that I had commissioned in the past, and turned our demo into this. These assets are all from the same asset pack that I mentioned giving away earlier. That's everything for this tutorial. Please consider leaving a like, comment, or even subscribing if you liked the video and want to see more tutorials like this. If you have any questions or want to request a specific topic for a future video, or just want to say hi, please leave a message in the comments. Like I said earlier, I'll also be giving away that asset pack to some of the people in the comments. Thank you for watching, and I hope you have a good day. Bye.